On this example, we're going to solve this equation by completing the square. And so what I taught you in the previous part of this lesson will help you get through this part. Now, we are going to scoot this over. Here, I'm going to use a different color. So y squared plus 6y equals -8. We need room to put in the part that's going to make this a perfect square trinomial. So if we take half of 6 and then we square that, 6 divided by 2 is 3, 3 squared is 9. So we're going to add 9 to both sides of the equation. Now remember, this is an alternative method to solving quadratic equations than factoring. Sometimes the equation would have factored, and you will be able to tell once you see the solutions on whether it would have factored or not. And then we write the perfect square trinomial on the left in factored form, right, as a binomial squared equals 1. Now, when we get to this step, now we're just applying the square root property, right? So when we go from here to here, that's apply the square root property. Okay, so that's going to make that y plus 3 equals plus or minus the square root of 1. And we subtract the 3, so -3 plus or minus the square root of 1 is 1. And so we have -3 minus 1 or -3 plus 1, which makes our two solutions -4 and -2. Now, this is an equation that would have factored, right? Y squared plus 6y plus 8 equals 0. This factors as y plus 2 times y plus 4. And you can see you would get those same two solutions, -4 and -2. All right, so if it comes out to be just regular numbers, right, real numbers, then that do not have any radicals, right? So they're rational also. Rational numbers, then we know that it would have factored. So we're going to be practicing this over and over again. So I'm giving you plenty of practice. Remember that you can always pause, practice, start up the video again and see how you did. And all of these now from here on out, we're solving by completing the square, which, as you just saw, includes the square root property. So we separate this a bit. Scoot the 6 over to the other side, so it's going to be a -6. Now I'm going to take half of 4, all right, divide it by 2 and square it. 4 divided by 2 is 2, 2 squared is 4, so it requires a 4 to complete the square and make this a perfect square trinomial. And then we write that in factored form and simplify on the right hand side. -6 plus 4 is -2. Now we apply the square root property, which makes this x plus 2 equals plus or minus the square root of -2. And then we have some simplifying, right? We've got to solve for x, so we're subtracting 2. And then we also are going to simplify the radical, which is -1 times 2. So this is going to be I radical 2. And then we have found our solution. Now these are the steps, right? These are the steps for completing the square. So if you get lost at some point, you can go back and read through this. Remember, I take snips of these out of our ebook, so that's why sometimes it seems a little distorted. If the coefficient of the x squared is 1, go to step 2. So I haven't shown you any yet where we have to divide. But if we do, we'll divide by the coefficient of the x squared term. Isolate all variable terms on one side of the equation, complete the square for the resulting binomial, factor the resulting perfect square trinomial and write it as the square of a binomial, then use the square root property to solve. So we've done steps 2 through 5 so far, and we will be, I'll have some examples where we'll need to do step 1 as well. Okay, and here's the first one where we have to do that. So first I'm going to rearrange a little bit. I need the 6x on the same side as the x squared, and I need the 3 on the other side. Now we have to divide by 6 because my leading coefficient has to be a 1 for us to be able to complete the square. That makes this then x squared minus 1x, right, equals 1/2. So this one didn't turn out too bad when we divided by 6. Sometimes you'll get some pretty messy numbers that you have to work with, and in fact even fractions. Now earlier we did take half of -1 and we squared it, which is 1/4. So we're going to add a 1/4 to both sides of the equation. Then we're going to write the left-hand side in factored form, so that will be x minus 1/2 squared. Remember, the number that goes here is always what you found when you took half of the coefficient of your middle term. Then we're going to add 1/2 and 1/4, which is 3/4. You know, I just know that, so I'm going to do that. You can always use your calculator. And then we apply the square root property. So completing the square is basically until we get to here, and then we use the square root property to finish solving for this for x in this equation. So x minus 1/2 equals plus or minus the square root of 3/4. Now, when you're taking the square root of a fraction, notice that the denominator is a perfect square, so we're going to be able to take the square root of 4 and bring that out of the radical, basically. So let's go up here. So x is 1/2 plus or minus the square root of 3 over 2. Right, so I'm just going to write it this way. This could also be written this way. So 1 plus or minus the square root of 3 over 2. Those are the same answer, right? So either way would be the same. Okay, we don't need to divide out anything this time because my leading coefficient, right, that's a 1. And so we just continue from here. X squared minus 10x. Remember, we isolate the variable terms on one side, and the constant term we move to the other side. So we're just subtracting the 2 to get it on the right. We're going to take half of -10 and square that, right? So -5 squared is 25. We will add 25 to both sides of the equation. On the left side, we'll have x minus 5 squared, and then that's equal to 23. This is where we apply the square root property, and that's x minus 5 equals plus or minus the square root of 23, and then we add 5 to both sides to solve for x, so 5 plus or minus the square root of 23. Those are our two solutions. Remember, this means 5 plus the square root of 23 and 5 minus the square root of 23. All right. Next, I'm going to isolate my variable terms on one side, and then we're going to take half of 14, which is 7, and when we square 7 we get 49, so we add 49 to both sides and write the left-hand side in factored form. On the right-hand side we just combine, right? We subtract, basically, well, however you want to look at this, a negative and a positive, so we're going to get -9. And then we apply the square root property. That makes this x plus 7 equals plus or minus the square root of -9. And then subtract the 7. -7 plus or minus. Now this is -1 times 9. And so that's going to be 3i. And so we have that solved then for x. Okay, so here's one of those messy ones. We are going to have to divide by 5 on everything, and we're going to rewrite this so that we isolate our variable terms on one side and move the constant term to the other side. So x squared plus 3/5 x equals 4/5, right? Add that 4/5 to the other side. Now, here's how I take half of 3/5. I'm just going to multiply it by, you can do this on your calculator. If you take 3/5 and divide it by 2, you'll get the same answer. All right, and then I'm going to square that. So that is 3/10 squared, which is 9/100. I know that seems like kind of a crazy bit weird number, I think, but that's okay. So 9/100 we add to both sides. And then we write this in factored form. So that's going to be x plus 3/10. Remember, another way you can figure that out is just the square root of 9/100, right? That's what's going to go there. Now, if I add these two together, oops, I'm thinking multiply by 20. I need a common denominator, right? So 5 times 20 is 100, 4 times 20 is 80. So here's what we have. X plus 3/10. I'll go ahead and keep that there until I have this. And then we apply the square root property. Now you guys can just use your calculators for that fraction part. So when we apply the square root property, this is what we end up with. We can take the square root of 100, so we will take the square root of 100 and that will come out. All right, so x equals negative 3/10 plus or minus square root of 89/10. All right, and that's it for that one. Now, that one got a little tricky just because of some of the kinds of numbers we had to use there. All right, so this is my last example, and I'm getting low on time here to finish in 15 minutes. We're dividing everything by 2 first. All right, that's going to give me a negative 3/2 on that side. Half of negative 2 is negative 1. Negative 1 squared is 1, right? So we're going to add 1 to both sides. And then write the left-hand side in factored form. So negative 3/2, that would be plus 2/2 is going to be a negative 1/2. And then we apply the square root property. Now this one ends up being a little bit trickier than some of the ones that we have done so far. We actually are going to have to rationalize this denominator. So I'm going to do that first. That's plus or minus I over the square root of 2, right? Because I simplified the square root of negative 1. And then we're going to multiply by radical 2 in the denominator to rationalize. Now this just happens every once in a while, but just so you know, this is how you would handle that. Okay, so let's go up here. Solving for x, we would add the 1 and write that in front of our plus minus. And so that's going to be the square root of 2 over 2, and then we write the I out beside it. If you wrote the I in front of the radical, that's fine. Or you could write it as, because I think sometimes they do this in your textbook. If we wrote this with a common denominator, then it would be 2 plus or minus I radical 2 over 2. And that would just be making the 1 as 2 over 2. And that's what happened there. All right. So we're finished with this lesson on completing the square.